This is the Physics 2211 Lab 1 constant velocity. The purpose of this lab was to observe the motion of an object moving at a constant velocity and compare the measured position to the predicted data. And to do that, we're going to use Newton's first and second law. And in this experiment, we should see that since there are no external forces, the object will not accelerate and it will maintain a constant velocity. The system in this experiment is the ball, and the surroundings are the friction and normal force from the carpet and the gravitational force from the earth. So Newton's first law states that an object in motion will remain in motion unless acted upon by an external force. So in this experiment, we should see that the ball will keep moving after I push it since there's nothing to slow it down. And Newton's second law states that the net force acting on an object is equal to the change in momentum divided by the change in time. So we should see is that the ball will remain at a constant velocity since there's no external forces, meaning that the ball should not accelerate. And this is a position and velocity update formula that will be important in the code later. So for the observed position, I rolled a ball and then put that video onto Tracker to see its position over time. As you can see, it's not quite straight, but it's pretty close to it. And the little circles in the middle is the center of mass, just measuring where the ball is at each frame. So using the data from Tracker, the frame rate was 30 frames per second, which is 0.033 seconds per frame. That's going to become the delta t in the code. The initial position was 0, 0, 0. And then to find the initial velocity, I used the first point and the second point to find the slope. And I got the initial velocity was negative 1.35500. And the end time was 0.733, so that will be the loop until variable in the code. All right, so here's the code. All the circles is the lines of code that I changed. So first I changed the mass to the mass of the basketball. I changed the initial velocity to the value I got in the last slide. I changed the loop variable to 0.733, changed the force vector to 0, 0, 0 since there is no net force, and then I used the velocity and position update formulas. And then this is a graph that I got using GlowScript. So if we compare that data, we see that the predicted position is greater than what was actually there. So there's obviously some source of error there. The most likely cause is friction. So Newton's second law assumes that there are no outside forces. However, the basketball was rolled on carpet, which applied a friction force and slowed it down. Also, the center could have been wrong. So the measured x coordinate in each frame may be slightly off, resulting in an incorrect position at each data point, and that could also cause an incorrect velocity when calculating the slope. Then also the ball could have been accelerating in the frame that I used since I did have to push it to get it moving in the first place. So the additional questions, if I rolled the ball from left to right, so then the position would have been in the positive direction, and the line would have been reflected over the x-axis so that it points up and to the right. And in the experiment, the gravitational and normal force were equal to 0. However, the forces in the x direction were not, as proven by the comparison graph. There was friction, and there could have been air resistance, which slowed the ball down.